model. For every word we generate sound models. So this is the feature extraction process. Actually, we started with framing and windowing. Maybe you are aware about that framing and window. 20 millisecond frame window is there, which shifts to 10 millisecond. For every frame, we are extracting the MFCC feature. So suppose in 1000 milliseconds, if 25 milliseconds window is there, then 40 frames will be there in 1 second window. Okay, so this is how we for every frame we extract the MFCC feature and we give to the models. So DFT, discrete Fourier transformation, then Bell filtering, then we take logarithm, then discrete cosine transform, then MFCC features are extracted. Okay, so this MFCC feature actually mimic how the human ear perceives the sound. So these are nothing but the feature extraction process. Then before going to the deep learning models or any models, we need to understand first traditional model like HMM, GMM model. Actually, the hidden Markov model is that I capture actually temporal patterns of the speech, that how sounds are unfold in time. Okay, this is a temporal pattern. Speech is the temporal pattern that changes over the time. So this hidden Markov model actually model the speech, and the Gaussian mixture model. So in weather forecasting, you might have heard we know the temperature values, right? We know the temperature values, but we don't know the exact. We can state that is today is a cloudy environment. How we say the cloudy environment? By seeing the temperature? No, this is the hidden states, right? We know the numbers, temperatures, right? So these are the patterns, right? And state is hidden, that is cloudy or rainy. Likewise, in speech also, we don't know the phoneme, we know the features, right? So if this is the pattern, then this patterns belongs to the particular phoneme, right? And the Gaussian mixture model actually what we can say, if I say word a is a sound, right? And maybe another person generate this sound a in different way. So my a and your a will be different, right? So it's a Gaussian mixture. For my a there is one Gaussian. For your a there is another Gaussian. So it's a Gaussian mixture model. So it captures the variability of particular sound, right? So this is how Gaussian mixture model. So and after this GMM, these are the traditional model. After that models, modern architectures evolved like RNN, LSTM. RNN, recurrent neural networks. It has the flaws of not having long-term dependency, which covered in the LSTM. Okay. Then transformer. You might have heard attention mechanisms, right? So transformer architecture is there. Conformer means convolutional neural network plus transformer. Convolutional, that your audio is converted into the image like spectrograph. Okay, and that will be given to the model. So convolutional part, and for the decoder transformer part is there. So finally, end-to-end SR architecture. So what is the difference between traditional architecture and modern SR architecture? In traditional architecture, we have to train feature extractor differently, acoustic model differently, that language model and decoder. So whole components we have to train separately. But in modern transformer architecture, modern architectures, we have to train one model only. Okay. So and in modern parallelism is there. Okay. So again. This uses the probabilistic modeling, and in transformer new architecture, self attention and contextual embedding. So these things are used. So these are, and modern architecture are very powerful in terms of accuracy. Okay. So another concept is there, self-supervised learning. You have heard, I think, ChatGPT, how this large language models train. So they actually extracted the data from all over the websites and all, right? And they train the language models. Okay, so the transformer architecture decoder part is here, right? So only they train the decoder part. Okay, transformer has an encoder and decoder, so they train only the decoder part. And decoder part task is what generate the next tokens. Okay, so they given all the text to the that unlabeled text to the transformer decoder, and they trained in such a fashion that it just predict the next one. Okay, in that fashion they train the models. Okay, so this is actually in self-supervised manner. Self-supervised means what? Without having labels, we are training the models. Okay, in speech also we have a lot of unlabeled data. Unlabeled data means what? Without having transcriptions. So what we did, we have trained the models, encoder part of the transformer architecture with any amount of data, right? Because the major task is what? Label data. We need a label data for training any model. But in low resource scenario, suppose there is a particular language in low resource nature, like Irani, Billy. These are low resource language. We don't have many speakers. We don't have a data. We don't have a label data, right? In that fashion, we can train multiple supervised fashion major languages data like Marathi, Hindi, English. Okay, so we will train encoder model. Okay, encoder model, and then we will fine tune with our low resource language. Okay, so two-way process. One is pre-training. Pre-training is training the SSL model with unlabeled data. Just train the encoder model, and then fine tune with the labeled data. Okay, this is two-way process. So this is one approach, is self-supervised learning and foundational models. So let's come to the. So what is our CDAC role is we have trained almost 13 Indian languages, ASR models, and also Stutlekhan advanced speech dictation system like Krishi Mitra and defense question answering systems. These are confidential systems, but we have developed for the that is our group has developed. So what is the voice to knowledge pipeline? Okay. So when you ask the query, whatever you are typing in the ChatGPT gives the answer. But instead of chatting, we give the voice query. Okay. So through voice only we get the answer. That is the voice to knowledge pipeline. So how this what are all technology involved in this process is the speech recording. First speech recording, then ASR model, automatic speech recognition, transcribe your speech, then text refinement is there, punctuations and normalization will be there. Then NLP pipeline like NER is name entity recognition, then summarization task will be there, translation task will be there, question answering task will be there. Okay, so these are some NLP tasks are there, and one model perform all these tasks like your large language model, and then finally your knowledge graph. So whatever the output you find LLM, then we present in the knowledge graph that reports will be there. So this is the voice to knowledge pipeline. So we need to integrate LLM and RAG, large language model, and RAG system, retrieval augmented generation, with the speech output. Okay. So this is the actually the integration. So ASR, then we put ASR output, that is the text output is the vector store. Vector store contain the embeddings of the text, speech, text, and then we use the LLM to answer the queries. So this is the. So we will understand what is how the question RAG system will work. Okay. Suppose we have a voice query. How many parameters are there in grok 0? Okay. This is the voice query. And already we have a documents and web pages. So what we will do, we will use split that documents into chunks. Okay, the big size chunk like 250 characters, and then we use the embedding model. What embedding model do? It will convert your text into numbers. Okay, and that will be stored into the vector database. So we have a database, vector database. Okay, then whatever the voice, whatever the question you have asked will be transcribed into the text, and then that text will be embedding model will be used, and that will be numbers. Then we have to search into the vector store, that vector database, and that will give the context. How many similar documents are matched with the current text? Okay, so there are multiple contexts will be retrieved from the vector database, and we will generate the prompt. What was the question? Text and the context. The answer may present in the context. Okay, so we'll take a question and your context, and we will provide to the large language model. Okay, so large language model will answer the question. So this is how the RAG pipeline works. So I would like to show real-time system at the end. So these are some challenges like low resource languages and data scarcity, but this can be handled by self-supervised learning fashion. Accent variations, code switching. People generally use Marathi and English together. Like the code switching, code mixing will be there. So this is the major challenge. Real-time decoding. This is one another bias, fairness, ethical data sets. Ethical data set means just record while collecting the data. You should inform the speakers why you are collecting the data. So these are some ethical things are there. Also, we as a responsible AI in speech, as we build powerful voice system, responsibility becomes essential, because deepfake voices can impersonate individuals, which raising the security concern. And ICCETAC is also developing Indian language deepfake detection systems, and I am also part of that. And our goal is to ensure speech AI is transparent, fair, and trustworthy. So these are some of the future direction: multimodality, speech understanding. So what is happening? We just don't have to consider one modality only, speech modality. Actually, people are using multimodality. Means what? At the same time, we are giving text and voice and image to one model. Okay, multimodality, and the model will understand. So if I give the answer text, what is spoken inside this audio, and if I give audio as input. Okay, so text and audio, these are two modalities I am giving to one model. Okay, so and model should answer me to, what is inside the audio. So these are the multimodality we are bringing. So I will tell the name. Quain model is there, Quain Omni and all. So you can explore that model also. So accent adaptive model and personalized model, like some people may have having what the terminology used for that having speaking problem. What we can say? Done. Right. So that problem, when if we train a particular model for that person only, then it will be, I think, the personalized model will be trained in future. Then on-device ASR for privacy. Like so all these models are actually large models, right? billion parameters are there, like they need GPUs to host, right? So if I train a small model, okay, and it will be deployed on my device only, that will be, I think, in remote places, if internet is not there, then I can, simply transcribe with the elbow. So on device ASR, that means your model should be, you know, in is small, and it will provide the accuracy, right? So why models are big? Because number of weight matrices are there. Larger the weight matrix, larger the knowledge. Understood? Larger the matrix, larger the weight. If your model is small, but it should accommodate more knowledge, then that will be a challenge, I think. So cognitive assistants that listen, understand, and reason. So this is the CETAC vision for India AI. So we are collaborating with academia, startups, government. Government is the key, actually. And this is the conclusion. To conclude, voice to knowledge is more than technology. It's about empowering citizens, breaking linguistic barriers, and democratizing access to information. And speech is the new keyword, bridge between people and digital intelligence. Thank you for listening. I hope this session inspire you to explore and contribute in the field of big technology. So I will demonstrate one system